Alright. Okay, sorry about that. For some reason it popped offline. Almost ready. Alright, let's head as soon as this comes up. Okay, so we're heading into here. I think we're at this particular point where we're looking at three-dimensional motion, or three-dimensional static. So in fact, instead of just some of the forces in X and Y, now we have some of the forces in X, Y, and Z. Now, you'll notice he goes from describing that to working a problem, because most of the material here you've already got. So let's just go to a problem and take a look at it. These are the F problems, so that's as good as one as any. Hang on. So he wants us to determine, okay, he wants us, it says it's a 150-pound crate. He wants us to determine the tension in these wires. Okay, so what I'm going to do is I'm going to notice that essentially we've got a tension running back this way, possible tension running back this way, and one running that way. And this thing is 150 pounds. The problem is, what direction is each of these? And so what I'm going to do is I'm going to call this TAB, TAC, and TAB. I'm going to start with the easiest one. I'm going to say the tension in AD goes exactly along the X direction. There is no other component. So I'll just drop all those. Then what I'll do is I'll start saying, okay, what is this one? Well, it's T, hello? Okay. TAB is this one. times the unit vector from A to B. So if I could find the unit vector in that direction, then I've got it. Now, in a minute, I'm gonna move these over to the right, and then I'm gonna find each of these unit vectors. And then what I'll do is to AC is equal to the tension in AC times the unit vector that goes from A to C. And then of course the weight will be that one. It's going to be nothing more than minus 150 because it's going in the opposite direction of Z and the K. So it's going negative or the opposite direction. So I have my four forces here. And so technically, I want to sum the forces in the X, the Y, and the Z. So what I'm going to do is I'm going to move these forces to the right, address the unit vectors, then I'm going to move that out of the way and come back with these. So I'm going to move these to the right for the moment. And then I'm going to address coming up with, let's see, it sent me a notification running. Let me make that, yeah. Make sure, oh wait. I have no idea what that is. Okay, so I'm still in there. Okay. Yeah. Okay. So YouTube sent me some notification, but I don't know what it is. So let's go in here and find I don't know, AB. Well, it's just a vector from A to B over its own magnitude. And so what I'm going to do is I'm just going to start trying to figure out that one. So first, I'll transverse the X. Looks like I went minus 6 down the X. I don't know why I'm being so particular. Then what it did is it went down here, and that's 3. And it went in the positive direction, and then it went up and got myself to B. One of the things I didn't start is octave. I think it's going to come, okay. So I'm going to do R, I'm going to do couple RAB is equal to minus 6, 3, and then a 2. And then what I'm going to do is UAB is equal to RAB divided by the norm, or the magnitude of RAB, gets me about 9.85, 714 I plus 0.42, 857J plus 0.28571 K. So, okay. So in other words, I take this, put it in here, put the norm in here, and I'll have UAB. Now, I've got that, and I've got it stored in memory in Octave there, or MATLAB, or whatever you want to call that. I'm going to slide that down and sort of put a box around it and say there's a calculation on unto itself. And I'm going to go back in, and I'm going to go after the next one. Oops, why did that not erase? Okay. So Now I'm going to find the UAC. And before I do that, I have to find the vector from A to C. I had to go 6 backwards in the eye, so this is the same place. Now I have to go here, go backwards 2, and then I have to go up 3 to get there. So again, this is the unit vector in that direction, and I'll go put this in octave and move that out of the way. So I get R, AC equal to, and pull out my vectors, minus 6, minus 2, and then 3, and that gives me my RAC, which apparently I have cap lock on. So okay, now I'm going to go into UAC is equal to RAC, as other norm of RAC, gives me that unit vector, and okay, it's minus 0.85 and 714I minus 0.2871J, and there's extra digits here, but I'm not going to write them. So it's 0.42, 857, and so I've got it. Now, I guess this one was a little longer than that one, but the beauty is, shrink it down. I'll kind of put it right there. Now what do I do? Okay, so this is its own entity here as well. Well, so what I do, I'll take the UAC, put it right here, and take the UAB and put it right here. And so what I'm going to do is going to list all these. Okay, so here's what I'm going to do first. Okay, so I'm going to take them and list them in each of these orders here down the page. And I'm going to say TAD, the vector is equal to TADI. And then I'm going to say TAD is equal to whatever the tension in AB is times, okay, I'm looking for UAB to be minus, okay, let me move this over, minus 0.85, and what I'm doing is I'm looking down here, grabbing this and writing it down here. So as you see me copy this, I'm copying this one to put here with the TA in front of it. TADI. So what I'm going to do, move my I here, and then I'm going to say plus 0.42, 857J, plus 0J, plus 0.28, it should be a TADJ, plus 0.28, 571, TAB, and a K, it's a plus 0K, and then what I'll do is I'll take this one, TAC equals to minus 0.85714, TACI minus 0.28571 TACJ plus 0.42 Okay, what I'm doing is I'm copying this one, putting it here, taking that equation and writing it down here. Okay, 42857T AC K, and then the weight is equal to 0I plus 0J minus 150K. Now, these are all the forces that are acting at this point A. So if I sum them, I'll get TAB plus TAB plus TAC plus W equaling 2. Now all I'm doing is I'm adding up this one, and I put it down there, and then I'm going to add up this one, and put it down for the Y component, and then I'm going to add this one and put it down there for the J component. So if I were to go ahead and do that, what I would get is TAD minus 0.85714, TAB minus 0.85714, TAC plus 0 is equal to, well, here, plus 0I, okay? So technically, this is what this is. So this is the same thing as that. Now, I'll do the J component, which is, again, I'm just doing this one, and this one, and that one, and that one, and then I'm going to write them all down. So I'm even going to carry the 0. 42857 TAB minus 0.28571 TAC plus 0 J. So again, what this is, oops, this one is, okay, all right. It does this sometimes. I don't know why. Okay, here. All right, bear with me. I don't know why it's launching another off here. It's running pretty slow today for some reason. When in doubt, start it over, go back to the draw, and then you can do that. So, or you can't do that, maybe. Okay, so this is nothing more than the blue up here. And then the final one will be the component here, all listed down here, which will be 0 plus 0.28571 TAB. That is a, you zoom in on it, that is a 1, and this is a TAB. And then plus 0.42857 TAC, again copying just out of the yellow, minus 150, and that gives me K. So again, this is nothing more than an addition of all those characters, all those numbers in there. So effectively at this point, what I have some of the forces in the X listed right here, I have some of the forces in the y listed right here, and I have some of the forces in the z listed right here. Now, independently, each one of these has to be 0, and therefore, I can write these down as equations. Okay. Now, I'm going to sort of cheat here, in effect, because I've got the ability to do that with this thing. Here's what I mean. Let me show you. And go in here and take the first equation. I know my handwriting is not great. Do a copy. I will go right here and do a paste. There's my first equation. That is the sum of the forces in the x. Since that's a 0, I'm just going to say that's equal to 0. That is one equation. Let's take the second one, but I'm going to skip around, copying the zeros. Here, place it about right there. And guess what? There is a second equation. First equation is from x, the second equation from y. They don't have to be that way. You can put the first equation as any one of them. And then my third equation, copy, I put it somewhere right in there. Then I've got my third equation, which is the z. Now I can put this as equal to 0, or I can just move the 150 over, and it becomes a plus. So we've got 3 equations, and let's see, how many unknowns do I have? I have this one, and that one. So I actually have 3 unknowns. Now, I know there are ways of doing this, which are substitutions, but there is a significant advantage towards listing these as a matrix, and I'm going to show you why and how. So here, I'm going to try to make it so I can move this to the right a little bit. I'm going to go ahead and list these in a matrix in which this equation will go first. It's the x equation. It doesn't have to go this way. The y equation and the z equation. And I'll have some numbers. And then I'll have, it doesn't matter the sequence you list down here, but you got to keep up with it. I'll list TAD, and TAC. So technically, this needs to be the column, TAD and TAC. So the coefficients of these 3 terms are listed down here. So let's go ahead and do that. Oh, well, let me go ahead and do this as well. Set up the right hand side, because as I'm doing each equation, I need to move those into it. Okay, the first equation, the coefficient of TAD is 1. Okay, the first equation, the coefficient of TAB is minus 0.85714. Okay, the first equation, coefficient of TAC is minus 0.85714. Let's go to the second equation. Coefficient of TAD is non-existent. It's 0. There's no TAD in this first equation. Coefficient of TAB, 0.42857. Coefficient of TAC, minus 0.28571. Okay, lastly, okay, so let me go ahead and do this. What's on the right hand side here? 0 and 0. Just go ahead and list the second equation. TAD is non-existent in this one. TAB on the other hand, I'll get the extra scratching off there. Okay, coefficient of TAB in that equation, 0.285 to 1. And I hope I've been copying them numbers down. Coefficient of TAC goes up there, 0.42857. And then the right hand side goes over here, 150. Now let's look at something interesting about this. Okay. And this is the reason I do this, is because, okay, so what I'm going to do, I'm going to do something interesting here. I'm going to copy these terms and adjust them. I'm going to do a copy. I'm going to come over here. I'm going to list this one right here. And then I'm going to come back. And then we get, okay, which one is it? UAC. So here's the UAB. Do a copy. Come over here, it's listed about right there. Now I'm going to play with these a little bit to clean them up. Now, effectively, this sounds weird, but in this one, the TAD is going straight to the left. So I never actually found the UAD except that a complete observation, it was I. So it went in this direction. The unit vector pointing down from A to D is just I. So with that, I'm just going to copy that. Put that right here. Now I'm going to try to make them, I'm going to clean them up a little bit, first of all. Get them next to each other, make them look a little bit better. As a matter of fact, what I'm going to do is put this one here, this one underneath that one, and then move this one over a little bit. Now, oops, to make them a little bit bigger so I can zoom out and okay. Now look real close and you will find something very interesting, and this occurs every single time. I'm not able to. This silly thing, why did it do this? Anyway, it's not responding very well. Here's the key. I was going to highlight. I can't highlight. You look at this vector. Notice real close here. In a column sense, this is listed this way. Okay, notice UAB is connected to TAB. Notice this. In column sense, if I did it right, this should exist as the column. This always, always, always occurs. In other words, 0.85 minus 0.85, they're both the same. 4.2, 4.2, both the same. 2.8, 2.8, they're both the same. Now, you have to be careful because if you list these X, Y, and Z in this form, X is the first row, Y is the second row, Z is the third row, this always occurs. always, always, always occurs. This one happens to be that one. 0.85 minus 0.85 sits right there. The minus 0.28 sits right here. And minus or plus 0.42 sits right there. So this is a sequence which occurs every single time. Especially easy if you list the X as the first row, the Y is the second, and the Z is the third. So with that in mind, let's head back to Octave. Okay. And I still a C. I had my UAC. I did not have one of the other terms. So here's what I'm going to do. I'm going to come up with a U, A, D, because I didn't have one. U, A, D would be equal to 1, 0, 0. Now, what I want these to be is listed in a sequence. Instead of rows, I want them to be listed as a column. So here's what I'm going to do. Take a K and watch this real close. I'm going to take the U, A, D, and do a transpose of it. And I'm going to try to see if this works. I cannot guarantee you that this will work. There is another way of doing it. Oh, I have to look real close here. Okay, now let's take a pause here and take a look at this and look at what I did. So I know this is not a MATLAB course, but at the same time, sorry. But let's take a look at the first thing. What is that? Here's UAD. Here's UAD with a apostrophe at it. And so what it does is it creates a column vector. Now if I take two column vectors and put them with a comma between them, I'll have a column vector, and a column vector. So just like that, I can have the matrix. So now all I have to do is do a right-hand side equals to 0. I have to make it okay, this makes it a row vector, a column vector with the comma. It makes it a row vector. But if I don't like that, I can put a apostrophe at it and it turns it back. It transposes it. So now I can do something really simple. And I guess I can do this. Inverse. Did I call that K? I hope I did. I'm going to assume I did. Times the right hand side. And, just because I want to double check. Yeah, that was a K. Okay. Now I've lost. Okay. Let me do it again. Okay, so there's my answer. 346.15, 161.54, 242.31, and I have them in the same order that I have here. PAD equals to PAB equals to, and PAC equals to. And these are my answers. Now, I do not know, nor do I remember. Okay, this was F3 11. Now, if I can, there's F311, not F311. So that I gotta go to the 3. Okay. This is not, for some reason, everything is very slow today. Okay, there's a mess that he's written here. So I think in the F's, what they do, we do all of it here. And so then he says the things that he gets. Okay, here. Is that it? Yeah. Okay, now I've got to go find where I was. Okay, I got done. I don't know how the page ends up moving like that. Okay, second. Too tiny. Okay. So first of all, I still can change things. So FB, which is my 2AB, and then FC, my TAC, and FD, my TAD, ends up like that. Now, the reason I do this the way I do is because if you look at this, and I don't know that we have time to do it today, if you just look at this and recognize that this always is a pattern, as long as you list X, Y, and Z first, you will get the base vectors or the unit vectors in columns here. So we have a unit vector here, a unit vector here, and a unit vector here. Now, of course, these are, I guess I should have done this. This one sits right here. This one sits right here, which I'm kind of repeating myself, and this one sits, of course, right here. This always occurs, especially if you list them X equation, Y equation, Z equation. So you got to be mindful of that. And the right-hand side is there as well. So, I guess at this point, I forgot to do the word of the day and dynamics. I feel really bad about that, but I'm going to try not to forget that here. I hope I don't have to do that. Okay, good. Man, everything is slow. Wow. I don't know why. You're sitting in this class. Okay. Wow. It's under content. Jeez. My email, our system, APU, U.edu. How about Walnut? There's your just word of the day. Okay. All right, so the question is, should I go? I don't think I have enough time to work another problem. Where is it? Right there. But next time what we'll do is we'll pick up. I'll set up the problems to work next time. Those are two good ones. So here, I'll go ahead and set this problem up. No. Like that. And grab this one and work this one and run this one. Now that we have our new technique, and then what I'll do is I'll grab this one. Oh, I didn't hold the key down long enough. I'll grab this one. I'll work it on Monday as well. And shoot, let's just do another one. We'll do another one on Monday. Oh yeah, here's a different one. Okay, that. We'll do all three of these on Monday. No, wait, yes, Monday. That's right. Because today's Friday. And so, let's see. Let me spin forward. Well, I like that one too. Maybe I'll postpone that until Wednesday. Maybe I'll do a couple of these on Wednesday. And I guess I really should do a spring one, just to let you know how annoying they are. Oh, and that's the end of the chapter. So I'll do those on Monday. Maybe on Wednesday I'll do a spring one, and we'll jump into the next chapter, which has to do with torque and moments. And so I hate to bail on you 6 minutes early. Let's see if I have that chapter up. Chapter 4, chapter 4, chapter 4. I do not see it, but I can go get it. And I'll need to get it anyway. Okay, so maybe I'll talk for a few minutes about it before we go. All it is dealing with torque. However, what he says here is called the moment. You know, you don't go out and buy a moment wrench, you buy a torque wrench. So what this is talking about is, okay, if you put a wrench on your tire and just pull on it, you're not going to be tightening the tire at all. So the key is to make your force perfectly perpendicular to be the most efficient, because you can be super strong and pull as hard as you can, you're not going to tighten or loosen that. So as it turns out, of course, moment is the force times the distance. However, it's the force times the perpendicular distance. And so what he does is he gets in here and talks about cross products, which will do that. And you have your right hand rule, and we'll talk a lot about that. And you get all the way down here, and it's all about the cross product out of this. And it turns out your moment is just R across the F. And so we'll delve into that more like Wednesday. But I think I'm going to go ahead and close it out. But